Assalamu alaikum. This is the demo of the graduation project Cayenne. Cayenne is a mobile ad-hoc networks routing system for tactical teams. As you can see here, this is the network. The one in the middle, C1, is a command center, and those are units. As we can see, every unit is only connected to one or two units, but through the routing that we implemented, they can all talk or communicate together. So how does this work is that every node runs in a separate network namespace in our testbed, okay? And then ManyNet is a tool that emulates wireless drivers and basically tells each unit what units it can, like, are within its range and what units it can communicate with directly. And then through the routing, they can all communicate together. And now we're running ManyNet to it's creating the network, and we're waiting for it to complete. Now it's completed. Now we're running the scripts that go inside every network namespace basically and runs the routers and the applications. And every application from inside exposes a port that we can plug into from outside to from the default namespace, so that we can run the applications now in the demo. Now we first go to the command center application, we plug into the router, and now we're logging in. We entered the correct credentials, so now we granted access. As you can see, these are the units as can be seen from the command center. They are divided into two colors for two multicast groups. We know their locations because they continuously send us their heartbeat signals and their GPS locations, as we can see in the top left. A red one is just the one with low heartbeat. Okay, so now let's go and see the unit application. We plug into two units, that's unit 11, and we also plug into unit 14. Now let's try and send a message from unit 14 that we need supplies, for example, and then we can see the message here arrive that we need supplies. It's routed through the network and to the command center. And now let's try the other way around. Let's try to send the message from the command center. Actually, let's try to send an audio to test all the different things. We can send audio messages, and now we're recording audio. Now let's go see, and the audio successfully arrived. We can see it in the audios, and we can listen to it on unit 14. Now let's test mobility. Let's see what happens when nodes are moving around. So we go to our testbed interface. First, we go to the map to see where the unit is initially. That's the red one. That's unit 14. Now we're gonna move it around and see what happens. Okay, so now we moved unit 14 a little bit, and then we can see it moving in the map because it's continuously sending us GPS signals, so we know where it is continuously. Now let's try to move it and then try to communicate with it while it's moving. So now we cause it to move, and then we go to its application and send a message from it to the command center. And then when we go to the command center, we can actually see that the message was received. We are in danger, please send help. We can also, if we go to unit 14, we can view the entire history of communications and other things. Like if we go now to unit 14, we can see, we can see the messages that that it sent us, and we can see the history of its location. If we zoom in here, we can see all the locations that the unit has been in because it's continuously sending us the GPS signals, and we can also see the history of the heartbeats. Now let's go on and try video streaming. Okay, so first we need to send a start streaming signal to the unit. So we go to a different unit. Now let's try unit 15, and we send a start streaming signal. Then we go to the unit application and make sure that we received it correctly. And now we actually wrote a script that takes a video and turns it into camera feed, and now we're going to run it to simulate streaming. And now it takes a little bit, so we're going to the command center. So we're just waiting for the script now to finish, and for the unit to start streaming. We're going to receive a notification here. So now we got the notification, and the streaming is running. Now we stop it. To stop it, we click here, and then this sends a stop signal to the unit, and we can go to the unit to check, and yes, we received an end streaming signal. Okay, now let's try multicasting. So we have here the purple group and the orange group. Unit 7 and Unit 8 belong to the purple group, while Unit 18 belongs to the orange group. So we're going to send a message to the purple group and see who receives it. And now if we go to Unit 7, we can see that it received the message, retreat to the page. If we go to Unit 8, the same. But if we go to Unit 18, it should not receive the message because it's not in the multicast group. But if we broadcast the message instead, everyone should receive it. So let's try to broadcast the message. We first enter the radius of the broadcast, and then we choose the type of the message. And we can see that Unit 18, which was out of the multicast group, received it. Unit 8 received it, and finally Unit 7 also received it. So everyone received it. Now let's go and see what happens under the hood. We wrote a script that takes the logs produced by the routers and then visualize the routes. Here we can see a message that went from one node to the command center, and we can see the path it took. We can see other messages that blue is the source, red is the destination, and green is just forwarder nodes on the path. We can see that it picks the shortest path according to the delays. We can see different examples of the path. It always takes the shortest path it can take. This is a dark neighbor, so no routing basically happens here. And we can see that even though some nodes are in different zones, so they have no idea where they are on the map, they eventually figured out due to the routing protocol. And yeah, that's it for our demo. I hope you enjoyed it, and thank you very much.